everyone, this is Sri Guru over here. Welcome back to my YouTube channel. Today in this video we are going to discuss about the kinematic equation. Right? What do you mean by kinematic equation? If the particle is moving in a straight line with a constant acceleration, then velocity, position and acceleration of the particle can be described by the certain equations. Right? That equations are known as kinematic equations. Okay. Now let us consider a VT graph, and these derivations are derived on the basis of velocity time graph. Right. And that velocity time graph, see here, along the y-axis we are choosing the velocity, correct, and along the x-axis we are choosing the time. Right? Now let us consider a particle is moving in a straight line with a constant acceleration, and that particle is having the initial velocity u, right, at the point A. This point I will take it as a, correct, and we know that this is at time, let u be the initial velocity at t is equals to 0, right? If the particle is moving with a constant acceleration, that means we should get the straight line, correct? And we consider at a particular point B, its velocity is a final velocity, and that is u. This is v. This is v. It's a final velocity at point B is v. Velocity at the time t. At a time t. Correct? Right? Now draw a perpendicular line to this. Okay. I will take this as a capital T. This point as a capital T. But this small t is representing what? The velocity of the particle at this point is t. Okay. Now draw a perpendicular line to this BT. Take this point as a C. Okay. Rather than get confusion, take this point as a D. Is it right? Correct? Now, what is this dB? This dB is what? V. Correct? And this OA is what? OA is U, correct? And what this OD? OD is nothing but T, correct? This distance is what? T, correct? If this OD is equal to T, then obviously this AC must also be equal to T only. If this is V, then what the distance of BC? V minus U. This is U, correct? V minus u. Is it right? Correct? Now listen here. Acceleration A is, to get the acceleration, whenever we take the area under the curve in a velocity time graph, that gives the acceleration. Correct? That is area under the curve. Correct? Or otherwise, A is equals to tan theta. If you take the slope of this graph, not the area, it is just a slope. It's just only the slope of VT graph. Slope of VT graph. That is tan theta. A is equals to tan theta. What do you mean by tan theta? That is this slope, correct? BC divided by AC. BC divided by AC. Right? That A, acceleration A. BC is what? V minus U divided by, next, AC is what? Time t. Now rearrange this equation. A into t is equals to V minus U, or V is equals to U plus AT. This is the first kinematic equation. Remember, V is equals to U plus AT, or take the snapshot of this board. Okay, in the second derivation, here we are going to derive the relation between distance traveled by the object and velocity and acceleration and time. Okay, for that, let us consider a particle is moving in a straight line, correct? And this is the origin. Okay, at its initial position of the particle is here, whose position vector is x naught at t is equals to 0, correct? After certain interval of time, the object traveled a distance x at a time t, right, from the origin whose position vector is x. Is it right? This is what, from O to x. O to this point, take this as a or P, and this as a Q. OP is equals to whose position vector is x naught. X naught, and this position vector OQ is x. Just remember here. Okay. Once again, draw a velocity time graph for a constant accelerating particle is moving with a constant acceleration. Okay. Now, once again, along the y-axis we are choosing velocity only, and along the x-axis we are choosing the time. Correct? This is the origin O. If the particle is having the initial velocity, that means at a time t is equals to 0. Just take this point as a and this distance as a initial velocity u. Correct? And the graph is a straight line from this point. Right? Now, at a particular point B, the particle is having the final velocity at a time t. Okay, this time, this from O to this is a time t, and this distance, this is what, from here to here, this is final velocity v. Now draw a perpendicular line to BD from A, and this point is a C, correct? Then this distance should be what? BC must be V minus U. This is U, right? V minus U, correct? Is it right? First note down all these points. Okay, now area under this curve AB, area under the curve AB, which gives total displacement of the particle. Under AB gives displacement, correct? Now displacement AB, okay, that means this x minus x naught, this is a total displacement, correct? Change in the position is a displacement. This is equal to half of sum of the parallel sides. Parallel sides into a perpendicular distance. Perpendicular distance. Note down this first. Okay. Now here x minus x naught is equals to 1 divided by 2 into sum of the sides means this what? AO plus BD. AO plus BD into perpendicular distance is AC. AC, correct? Now 1 divided by 2 x minus x naught. This is x minus x naught. This is displacement into OA is how much? Initial velocity u plus BD is how much? Final velocity v into perpendicular distance. Perpendicular distance is what? Time taken t. Okay, is it right? Now, but x minus x naught is displacement that I will represent as a yes. Okay, and v is equals to u plus at. V is equals to u plus at. Therefore, replace this with yes is equals to 1 divided by 2 into bracket u plus, in the place of v write u plus at. U plus at into t, correct? Then s is equals to 1 divided by 2 into 2u plus at into t. At into t. S is equals to 2 get cancel, u into t plus 1 divided by 2 a into t square. This is the second equation to get the displacement of the particle moving with a constant acceleration. Then use this equation, s equal to ut plus half at square. Okay, note down or take the snapshot of this board. Okay, next another important derivation, velocity attained by the particle after traveling a certain displacement. Yes. Okay, then how we can calculate that? Once again, using the graph only, we are going to derive that equation. Once again, the particle is moving with a constant acceleration. Therefore, the graph is like this. If the particle is having the initial velocity, then it starts from the a at the time t is equals to 0. This u is what? Initial velocity. After certain interval of time t, this time t, the particle reach a velocity v. That I will take it as a final velocity v. Okay, and draw a perpendicular line to this BD, that is AC. That BC value become v minus u. Okay, now once again, area under AB, area under this AB, which gives displacement. Okay, area under AB displacement, right? That is yes is equals to, as we used in the earlier equation, once again apply the same equation, half into bracket sum of the two parallel sides, sum of the parallel sides into a perpendicular distance, to this. Okay, now s is equals to 1 divided by 2 into bracket sum of the parallel sides, that is OA plus DB, OA plus DB into perpendicular distance is AC. We know all the values of OA, BD and AC. Just s equal to 1 divided by 2 u plus v into t. Okay. In the previous derivation, we discussed that this acceleration A is equals to change in the velocity divided by time. Okay, that is acceleration is equals to v minus u divided by t. Correct? T is what here? AC. Can we rearrange this as v minus u divided by acceleration? Just I have taken this AC to here and A to here. Okay, now substitute, this is what? T, right? Substitute this value into this equation 1. Okay, substitute T value into equation 1. Then s equal to 1 divided by 2 u plus v into bracket v minus u divided by a. Can we take this 2 and a to the left side? Then it is 2as, correct? Multiplication with 2 and a. This 2 and a will come with the multiplication with s, right? What are the remaining term? U plus v into v minus u. You can write this as a v plus u also. Okay, this is in the form of a plus b into a minus b, a square minus b square. That is 2as is equals to v square minus u square, or otherwise v square is equals to u square plus 2as. Remember, all these three derivations, these are most important derivation. Okay, thank you for watching my video. In the next video we are going to solve some numericals based on these equations. Thank you.